Hello engineers, welcome to the first section of the course, and in this particular section we are going to deal with the very first mini project based upon opamp, and the name of our project is 9-volt battery level indicator. So as the name suggests, basically we are going to see the voltage present in our 9 volt of battery. We are going to check that particular voltage present in our battery. We just need to check that by what amount our battery is charged or by what amount our battery is being discharged. So that is our agenda. So let's read our agenda. So it is clearly mentioned that our aim is that our circuit should check the voltage or charge present in a 9 volt of a battery and display it at the output side. Okay. Note, we have to design our circuit using an opamp. So you will get lots of other circuits which had used controllers and some other circuitries out there, but our course is specifically designed for opamp. That means we are going to implement each and every mini project based upon opamp. So for that very purpose, we are just going to use opamp. I hope you are able to understand this, right? And since as the name suggests that we are dealing with 9 volt battery level indicator, so basically for that very purpose we will use 9 volt of battery, and strictly we are going to use opamp, right? So this is how the internal structure of opamp looks like. Great. So now let's proceed further and let's try to decode this particular agenda in detailed way. So let's proceed further. So yeah, let's try to decode our agenda. See, we need to identify how much amount of voltage is present in our 9 volt of battery, or in other words, what we really need to focus upon is how much percentage of our voltage is present in a 9 volt of a battery. So basically, whenever you deal with this kind of projects wherein you need to identify the percentage, wherein you need to constantly monitor the battery, right? By what amount your battery is charged or by what amount your battery is discharged. In fact, if you use your smartphone over there as well, you can see that by what amount your battery is being discharged, right? So 94%, 95%, 55%, 50%, right? So basically you always see the percentage whenever we deal with projects which involves identifying the percentage and a percentage of our battery, right? So remember, whenever you are dealing with this kind of project, you should focus upon the percentage of your battery. So assume that our 9 volt of battery, it is delivering 8 volts. That means it is delivering around 90% of the overall voltage. What does that mean? That means, see, 90% of overall voltage, which is 9 volts, is equivalent to, you can solve it in this way, that is 90 by 100 into 9. So this is 0 and 0 gets cancelled. We have 9 9s are 81. So 81 divided by 10, that is 8.1 volts, which is approximately equivalent to 8 volts, right? Which is approximately equivalent to 8 volts. Okay. So if this particular battery, if it is delivering 8 volts, that means what I can say is that this particular battery has around 90% of its overall voltage, or basically it is charged by 90%. This is what I can say. Okay. This is what I can say. Great. Let me erase this and let me erase this as well. So now you look at this particular calculation. You see, when my battery, if it is delivering around 6.75 volts or around 6 volts, what I can say is that my battery, that means my 9 volt of battery, it is around 75% charged, or it has around 75% of the overall voltage. Similarly, if my battery has around 50% of the overall voltage, what does that mean? That means it is delivering around 4.5 volts. Similarly, if my battery, if it is delivering around 2.5 volts, what I can say is that it has around 25% of the overall voltage. That means 25% of 9 volts, it is 2.5 volts, and 0% is anyways 0 volts only. So what I had done over here is that instead of taking this decimal values, I just considered this integer values. Okay, 6 volts, 4 volts, 2 volts, and 0 volts. Yeah. So the percentage may fluctuate. So it will be around 70 to 75%. This will be around 45 to 50%, right? So 4 volts is around 40 to 45% of the overall voltage. 2 volts will be around 20 to 25% of the overall voltage. I'm not taking the exact percentage. I'm just taking the rough estimation, right? So this will be around 70%. Similarly, this will be around 40% and so on, right? So I just taken a rough value instead of taking, I had just taken the integer value rather than taking these decimal values. Okay, great. So now let's proceed further and let's try to decode that how exactly we are going to design our circuit. What will be our logic, right, to design any to design this kind of circuits, right? So let's proceed further. Okay, so now that we had seen this, we had just tried to take the integer values. Now let's try to decode the further things. So we need to detect the voltage of the battery and compare it with the respective voltages and display it at the output side. Okay, so you see over here, this is my battery. So our first intention is to detect the voltage that is coming out of the battery. So we need to detect the voltage. Let's suppose if the voltage is, let's suppose, 7 volts. So we just need to first detect this particular 7 volts, and then we need to compare this particular 7 volts, like if this particular 7 volts, if it is greater than some reference voltage. Now what exactly is the reference voltage, or respective voltage? What does that mean? That means the voltage that we had calculated over here. So what we are aiming is that we are detecting the voltage present in our battery, and then that particular voltage, it should be compared with the respective, or basically the reference voltages. That means we should compare it with 6 volts or maybe 4 or maybe 2. Okay, we need to compare this particular voltages. Okay, and then we need to display it at the output side. So this is the basic idea. I hope that you are able to understand this. Okay, I hope that you are able to understand this. And since we cannot display the percentage of our battery, as it involves programming controllers and obviously one display unit. That means if you want to display, let's suppose if I want to display that the 9 volts of battery, it is 90% charged, or it has around 90% of the overall voltage. I cannot show this 90% at the output side. Why? Because to show this 90%, I will require one display unit, that is LCD, and we all know that LCD has that hex codes and all. So to to match that hex codes, obviously we need controllers to check the hex codes and all. And for controllers, obviously when we deal with controllers, so programming is involved in that. So we will be dealing with C language and all. So instead of making this particular project so complex, it's better to use opamp and make it as simple as possible, right? And as I had clearly mentioned that in this course we are specifically dealing with opamps, right? So strictly we are bound to use opamps only. Okay, so what else can we use instead of going with such complex circuitry? So we can actually make use of LEDs. Okay, we can actually make use of LEDs in this kind of setup. Getting my point? So what we can do, or rather what my agenda is, or what my logic is, see, whenever you design any circuit, you should first focus upon the result. What should be your outcome? Like your outcome should be according to your desire. So what I want, or what my desire is that, see, what I want is that in our circuit, if our battery is around 90% charged, then all the LEDs should be in on condition. Okay, that means let's suppose if my battery, if it is delivering around 90% of its overall voltage, that means around 8 volts. So if this particular battery, it is delivering me 8 volts, so all the LEDs, now we really don't know how much LEDs are present over there. So all the LEDs, they should be in on condition. Okay, they should be in on condition, all the LEDs, right? Okay, this is what I want. This is my desire. Okay, because I am designing the circuit, so I am I'm the one who is going to decide what I want and how my project or how my circuit should function. Okay, so this is the very first thing that I want. Then moving further, let me proceed further. Okay, if my battery, it is 70 to 75% charged, then only 3 LEDs should be on. Okay, only 3 LEDs should be on. So that means what? You see, if my battery, if it is delivering around 6 volts, then only 3 LEDs should be on. That means this over here, instead of all, you should put 4. So over here you should put 4. So I require 4 LEDs to show that my battery is in on condition. My battery is 90% charge. I only require 3 LEDs to show that my battery is delivering 6 volts at the output side, right? So that means it is around 70%, right? Similarly, if my battery is delivering around 4 volts, so what does that means? That means my battery, it is 50% charged, or basically it is discharged by 50%. This is what I can say in other words, right? So if it is delivering around 4 volts, so at that time only 2 LEDs, they should be in on condition, right? Similarly, if a battery, 9 volt of battery, if it is delivering only 2 volts, so in that case only 1 LED should be in on condition. This is what it means, right? I hope that you are able to understand this particular concept. See, as I already mentioned, whenever we deal with projects, your result, I mean, you should be process oriented, but you should focus upon your results, your desires, right? What you want at the output side, and based upon that you should focus upon the process, you should focus upon the designing part. So this is what our aim. So our aim is that if my battery is 90 to 95% charged, right? So all the four LEDs, that means I'll connect 4 LEDs. I don't know how I'm going to connect that, but what I want is that my 4 LEDs should be in on condition. If my battery, if it is delivering 6 volts, that means it is saying that, or it is stating me that battery is 70% charged, right? So in that case only 3 LEDs should be in on condition. Okay. Similarly, if my battery is delivering 4 volts, then it is trying to tell me that my battery is discharged by 50%, or rather it has only 50%, right? 50% of the overall charge. So in that case only 2 LEDs should be in on condition. Okay, same goes with the 2 volts. In that case only one LED will glow, right? Only one LED will be in on condition. I hope that you are able to understand this. If you want, you can just take a screenshot of it, because I'm going to erase this. Alright, I believe that you all guys might have taken a screenshot of it, so I'll just erase it because it's not required. This is just for the explanation purpose, so that you should not get confused whenever we will deal further. Okay, let me erase this and let me proceed further. I hope that you are able to understand this particular concept properly. Okay, this is what our outcome, this is how our outcome should be. Now let's proceed further and let's try to decode few more things. Okay, so as discussed above, as discussed in the previous slide, we need to detect the voltage, okay, plus we need to compare it with the reference voltages. Just highlight this particular word, compare. Just make sure that you highlight this particular word, compare. Compare it with the reference or the respective voltages, and then we need to display it with the help of LEDs. Okay, as I had already mentioned that we need to detect the voltage. Over here only I had mentioned detect the battery voltage, and then we need to compare it with the reference voltage. I again took this particular line because of some reason. Let me proceed further. Now what does that mean? That means the word itself states that we need to make use of opamp as a comparator. So basically we should operate opamp as a comparator in this particular mini project. Okay, so what a comparator does, it actually compares it to different voltages, and then it gives plus VCC or minus VCC depending upon the input voltage it gets, right? So I'll just read this particular line for you all guys. That means we need to use opamp as a comparator. We need to use opamp as a comparator to compare the battery voltage with the reference or the respective, with the respective reference voltage, and indicate the result with the help of LEDs. Getting my point? So what does that mean? Let's proceed further and let's see what I want to convey. Yeah, you see over here, this is my comparator. I'll provide certain reference voltage. So this reference voltage can be anything. Let's suppose it is 6 volts. Let me change the color. Yeah, let's suppose it is 6 volts. Okay, and my battery, if it is delivering, let's suppose this is my Vx is nothing but the battery voltage. Let's suppose if it is delivering 8 volts, that means my battery is delivering 8 volts. That means 90% of the overall voltage is being there. That means what I can say that my battery is indicating that it has been discharged by 10%, but it has around 90% of the overall voltage. So that's why it is delivering 8 volts, right? Now you see the comparator will compare these two voltages, and based upon that, the LED will be in on condition, or else it will be in off condition. So now you can clearly see my battery voltage, it is greater than the reference voltage, so therefore LED will be in on condition. Okay, this is what I had written over here. If you guys can remember that I had written over there, right? Or in fact you can see, if my battery is around 90%, that means around 8 volts, right, then all the LEDs should glow, or they should be in on condition. Glow means they should be in on condition. This is what I had clearly mentioned, right? As of now, just for explanation purpose, I had just taken one LED, one comparator. Okay. When I say that we will be requiring 4 LEDs to display this particular result, right? To compare these results, okay, and to display the output in form of LEDs, okay. And I had clearly mentioned that we will be using 4 LEDs. That means we will be using 4 comparators to design our project, okay. But the most important point is where we are going to connect the reference voltage and where we are going to connect the battery voltage. So that is the another point. Okay, so let's try to see that. What we want is that, if my battery voltage, if it is greater than my reference voltage, then my LED should be in on condition. This is the basic idea, right? But we really don't know. Let's suppose if I'm a beginner, if I'm not that much comfortable with opamp, I'll try to play with the input pins. Let's say if I'm connecting the battery voltage maybe over here. Okay, now let's suppose if my battery voltage, if it is delivering 8 volts, right, and this is my reference voltage Vref, right, it is set to 6 volts. Okay, we don't know how exactly we are getting 6 volts. We'll see that particular part as well, but as of now, just think that somehow we are able to get 6 volts at that particular terminal. Great. Now you see over here, this opamp will compare, and I hope that you all guys have a basic idea about opamp. If not, then I request you that you please make sure to enroll in the previous course of opamp, where I had explained each and everything about opamp in great detailed way. Okay, so I hope that you are able to solve this kind of circuit. It's pretty simple. It's a basic comparator circuit. So what opamp will do, opamp will just compare these two terminals, and it will see that it is getting quite higher voltage at the inverting terminal, so it will provide minus VCC over here. Minus VCC, that means if my VCC is 5 volts, so over here you will get minus 5 volts, over here. Okay, you will get minus 5 volts over here, and you see you are getting minus 5 volts over here, and you are getting 0 volts over here. So basically your LED will be in off condition. Your LED will remain in the off condition. So this is what we want? Absolutely not. So our assumption is absolutely wrong. Why? Because our LED is in off condition. In this case, our LED is in off condition, and this is what we don't want, right? We really don't want this kind of stuff. What we want is that when my battery voltage exceeds about the reference voltage, then my LED should be in on condition, and over here the case is reversing. So I know most of the guys will say you just need to change the polarity of the diode. Why to do so? Instead of that, you just change the connection over here. Let me erase everything over here, and let me explain you each and everything, so that it will be easier for us to understand it in detailed way. Okay, so instead of connecting reference voltage over here, what I'll do, I'll just connect reference voltage over here. Okay, so over here I'll connect reference voltage. Let's suppose it is 6 volts, and I'll connect battery voltage. Let's suppose Vx, it is 8 volts. My battery is delivering 8 volts. So now it becomes pretty easier. So opamp will compare these two voltage. It can see that to its non-inverting terminal, it is getting quite higher voltage as compared to the inverting terminal. So it will provide plus VCC, that is 5 volts. Okay, so over here you are getting 5 volts plus 5 volts, and over here you are getting 0 volts. So therefore this LED will be in on condition, and this is what we want. This is what we want. So thus, we are somehow able to achieve the result. Somehow we are able to achieve the result, but still the work is not completed. Some part is pending, and that is we want to do this kind of stuff with other 3 comparators. We had just tried to we had just tried to do this particular process with one comparator, but we need to do it with rest other 3 comparators as well. So before going to that particular part, I hope that you are able to understand this, or I'll just skip it as it is so that you should not get confused over here. Yeah, okay. So before going to those 3 comparators, we'll just try to build a rough block diagram. Okay, we'll just try to build a rough block diagram of the project. Okay, so this is how the block diagram will look like. As I had clearly mentioned that we will require 4 LEDs. So this is our first LED, this is second, this is third, and this is 4. And when I say that we will require 4 LEDs for this particular project, so I'll require 4 different comparators, 4 comparators as well in this particular circuit. And on top of that, we need to provide a constant reference voltages, okay, to this particular op-amp. So what does that mean? That means, let me just show it over here. Yeah, this is how the entire block diagram will look like. See, whenever you design any project, whether it may be related to machine learning, artificial intelligence, or maybe any electronics project, you should first focus upon the result, right? I mean, you should be quite comfortable to know that what your result should be. That means what result you should expect at the output side, but to achieve that particular result, you need to follow the process. And to follow the process, you need to have one roadmap, and that roadmap is nothing but your block diagram, right? So that's why block diagram is very, very, very important. Generally, I had seen most of the students, they skip the block diagram, they just focus upon circuit, they complete the circuit, and then that's it. They will play with the output. They don't follow the process. Just remember, whenever you are designing anything, whenever you are making anything not related to electronics in your life, if you are designing or if you are making any creative stuff, you need to have a roadmap. Without a roadmap, you cannot design anything. So roadmap over here is nothing but a block diagram, and this is how a block diagram will look like. So you see over here, I'm providing certain reference voltages. So basically this is my reference circuit. Okay, now you don't focus upon this particular point, that how exactly I have designed this particular reference circuit. Okay, don't focus upon this particular point. Okay, we'll come to this particular point in the next session. The most important thing is that somehow we are able to provide a constant reference voltage. So as I had already said that I'm going to use this integer values, that is 6 volts, 4 volts, 2 volts, and 0 volts. So obviously you need to compare from bottom to top. Okay, so what does that means? This is what it means. So over here you should get 2 volts. Okay, so this is the first reference voltage. Over here you should expect to get 4 volts. Over here you should get 6 volts, and over here you should get 8 volts. So what does that mean? That means it indicates that my battery is 90% charged. It indicates that my battery is around 70 to 75% charged. It indicates that my battery is around 50% charged. And it indicates that my battery is around 20% charged. Right? This is what it means. So we need to compare this particular voltages with the input terminal of the battery. So obviously we are going to connect a 9 volt of battery over here. Okay. So at the same time, you are going to get the voltages on all of this particular comparator. So not necessary that whatever the battery that we are going to connect, it is providing me 9 volt. Sometimes it will provide 5 volts. Some battery might provide 4, some might provide 3. Okay, but this is my overall input voltage, and this input voltage is being fetched to all of the comparators. So obviously I hope now you all guys know just by looking at this particular circuit, we are providing reference voltage to the inverting terminal. So we are providing reference voltage to the inverting terminal. So this is my reference voltage which I am providing to the inverting terminal, and this is my battery voltage. So this is my battery voltage which I am providing it to the non-inverting terminal. So this is my non-inverting terminal, right? This is my non-inverting terminal, right? Getting my point? And basically with the help of comparator, we are comparing these two sets of voltages, right? If my battery is delivering 9 volts, complete 9 volts, so for sure all of the LEDs will glow. Why? Because you see 9 volts, this V is connected to all of the comparator, to the non-inverting terminal of all of the comparator, right? So you see 9 volt is greater than 2 volts, so this LED will be in on condition. Similarly 9 volt is greater than 4 volts, so this will also be in on condition. Similarly this 9 volt is greater than 6 volts, so this will be in on condition, and this one as well, 9 volts is greater than 8 volts, so this will be in on condition. Okay, so now let's suppose somehow this battery, it got discharged by some amount. Let's suppose now this particular battery, if it is delivering 7 volts, right? So now all of this particular voltage will decrease by 2 volts and it will give 7 volts at the non-inverting terminal of all of these particular op amps, right? So now what is going to happen? You see 7 volt is greater than 2 volts. This LED will be in on condition. 7 volt is also greater than 4 volts. So this LED will also be in on condition. 7 volts is greater than 6 volts. So this LED will be in on condition. But over here 7 volts, it is less than 8 volts. So this LED will remain in off condition. Getting my point? This LED will be in off condition. Okay, and these 3 LEDs will be in on condition. And if you check very clearly, this is what I wanted. Okay, or this was my desire. This is how I wanted my end result, and this is how I'm getting, right? I hope that you are able to understand this. So this was all about the session. I really hope that you enjoyed this particular session. In the next session, what we'll do, we'll just try to decode this particular circuit diagram. That means how exactly we are going to design this circuit, which can actually provide a constant reference voltage of 8 volts, 6 volts, 4 volts and 2 volts simultaneously. That means at the same time it should provide all these constant reference voltages. Okay, and then this particular reference voltage, it needs to be fetched to this comparator. Obviously we are going to connect one input voltage, that is nothing but our battery. Okay, this battery will deliver certain voltage that needs to be compared with this reference voltages, and based upon that, you will get output at the output side, which is being displayed with the help of LEDs. Getting my point? Great. So I really hope that you understood that how we started the session, what all points we focused upon. So these were the points. That means the percentage, whenever, as I clearly mentioned, whenever you are dealing with this kind of projects wherein you need to show the percentage of battery charge or discharge, you focus upon the percentage, this particular term, and based upon that you conclude this particular things. That means, as I had clearly shown over here, we had taken some rough integer values to be precise, and then this will act as our reference voltage, and taking this as a reference voltage, then we compare this reference voltage with the voltage coming from this particular battery. Okay, and then we actually focus upon the output first. So this is what our output should be. That means 4 LEDs should glow if my battery is charged by 90%. 3 if my battery is charged by 3 LEDs should be in on condition if my battery is around 70% of the overall voltage. 2 LEDs should be in on condition if my battery is around 50% charged, and so on, right? And since we are quite quite aware of our result, what we know is that we need to compare reference voltage with our battery voltage, and that's why we are using op-amp as the comparator. This is how we are going to use it, and this is the overall block diagram of our circuit. And I really hope that you understood each and everything, each and every point that we have discussed till now. But still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section. I will be happy to help you out there. So thank you for listening me patiently. I'm ending this video over here, and in the next video we are going to decode this particular circuit. That means how exactly we are getting constant reference voltage at the same time. Okay, so thank you for listening me patiently. I'm ending this video over here. Thank you.